Here's an old classic, a Tektronix 515A oscilloscope. This was given to me by a friend of mine. Thank you, Ralph. And don't know any of the history of it as far as if it's worked in a while. It looks like it's been stored in either a barn, because I see a bird has made a contribution here. So it needs a lot of cleaning. I haven't opened it up yet. I'm definitely not going to power it up until I check it out. If you're into restoring old Tektronix scopes, especially the old doghouse scopes, I recommend a book here by Stan Griffiths. This came out, I think, back in the early 90s, and I don't know if you can still get a copy of it, but he covers just about every old Tektronix scope throughout its history, going way back. Very extensive. I wish they'd do one on the 7000 series and some of the newer ones. Maybe someone will get the hint, but anyway, the 502A, I got a 502A. That's actually a nice scope for audio. It's only 1 megahertz, but you can measure down to 100 microvolts for division on it, so it's pretty sensitive. No plugins in these either. But anyway, back to the 515A. Here's the description by Stan. 515A is an upgraded version of the 515. Like the 515, it has vertical bandwidth of 15 megahertz. That doesn't seem like much, but it's pretty good for audio stuff. I used my old 502 for audio stuff. That one was a dual beam scope, so it was pretty nice. But it has a little more sensitivity, 0.05 volts per division instead of 0.1 in the 515 non-A model. It says early 515As had selenium rectifiers. If that's true, they'll have to go. A 515A could have cathode interface on the vertical amplifier. That's a problem with these old scopes. But we'll find out. What I'm going to do before I do anything, I'm going to clean this thing up because it's pretty filthy, as you can see. The filter looks pretty dirty. The controls all seem to operate, but you can tell they need some TLC. Yeah, volts per division here. That's pretty hard to turn. I'm not going to run them too much until I oil the controls and clean the contacts in it. So I'm going to clean it up, and then I'll be back and we'll open it up and see if we see any surprises. Stand by. Well, it had its initial bath, and this thing is filthy. Or was. The front's looking better a little bit. Luckily, the CRT looks good. I don't see any burns in the phosphor here. But one of the things I don't like the looks of. This does not look promising here. This really needs to be given a bath. Believe it or not, Tektronix used to put these in dishwashers and wash them. I'm not going to do that now. Maybe in the summer when it gets hot I can clean it out, soap and rinse it, and then put it out on the deck in the sun for a while. But this doesn't look very good. It's got all the tubes. Yeah, these things were caked with dirt. Let's take a look on the bottom. Electrical tape and wire nuts. And looky here, we've got C601 is touching the chassis. That's not a good thing. And the phenolic part is broken here too. That'll have to be addressed. A lot of the capacitors everybody throws out before they check it out, which I'm not going to do that. I want to put it on a dim bulb and a variac, bring it up slow and let it cook a little bit, and measure the current and watch, keep an eye on the current. Beautiful transformers. That's one of the things I've always loved about Tektronix, is their transformers. So many people snatch the tubes out of these things to use them for audio applications. I hate that, because basically if that happens, you're not going to get it working. A lot of these are matched tubes. You know, especially in the old 502, you had to have specially matched tubes if you wanted the thing to work up to specs. And if you just put a random tubes in those things, it's not going to work. Well, I'm going to check this connection out. This definitely is not going to stay. I guess for testing purposes, maybe. This I'll have to make sure it's not shorted. And then I think the next step, I'll put it on the variac. I'll put it on a dim bulb, and then a variac will bring it up slow and see what we get. And that will be next. A couple preliminaries. I turn the switch on, making sure there's not a dead short on the input before I give it the first test. And I made sure that there were no shorts. This is, I questioned this. I made sure there was no shorts to ground from that cap. Well, I got it on the dim bulb current limit. Let's see what happens. Probably not a good sign. Not enough voltage to get the kilowatt going here. I have a 60 watt bulb, so that's limiting the current to about half an amp. Well, the fuse has got to be good. I got a little glow in some of these neons. See if I get any slight filament glow. Some of these are pretty bright when they're conducting. Oh, another good reason to give it the shake test. I gave it the shake test. Now I can't find it. Anyway, a nut fell out. So it's always good to give it the shake test, make sure nothing's shorting out here. I did hit a lot of the switches with deoxit contact cleaner just in case it fired up. I'm going to leave this on the dim bulb for a while, and then I think I will hook it up to a variac with an ammeter, an AC ammeter, and see what happens as I bring the voltage up. That just seems awfully bright to me. Although these do pull a lot of current, so I mean, you got a lot of tubes and heaters in here. Okay, I ran the variac up to 110 volts. I'm pulling about a little over 2 amps of current. And I noticed my high voltage rectifiers aren't glowing. And obviously you're not going to have any high voltage here. So we've got a problem with the high voltage circuitry. Turn the light off here. Yeah, those filaments should be glowing. The other tubes seem to be glowing alright. I don't see any dead filaments. The CRT filament is working. I can see that in there. So we have to find out where the problem is here. Scale illumination's working. So I have to go to the next step, I guess. Here's a schematic diagram of the Tektronix 515A power supply. Now I'm going to start here first. I measured the ESR of the main filter capacitors coming off of the bridge rectifiers, And the ESRs were within limits, except this one, C621, was a little bit out of tolerance, but I don't think enough to cause any trouble. 621 is right here, and this is a 2-section 20 microfarad cap. ESR is a little bit high. Starting here, the plus 400 volt unregulated, you've got a bridge, and you've got two caps, C660 and 661, that filter the output of the top bridge rectifier here. C661 is this one, and C660 is this one, and they're both in parallel. And their ESR look fairly good, within limits anyway. At least not enough to cause trouble. I'll have to look at the ripple and see what that says. Moving down to the second bridge here, you've got C630 and C631. C630 and C31 here, they're in parallel, and their ESRs look fine. And moving down to the bridge down here, you've got C601, which is right here. This is the one where, looking on the top of the unit, on the top of the frame here, they had used some silicone to try to keep it from moving. It had broken, but I put some tape to insulate it so it's not touching the chassis. So those are the main filter caps. Like I say, I measured the ESR on those caps, and they look to be within limits. So I think what I'll do now, I'll power up the unit and check the voltage across those caps, and make sure they're at the proper levels to drive the regulators. The only really regulated supply here is the minus 150 volt down here, and they use a 5651 gas tube to regulate, and then the other voltages are derived from that one. They use that as a reference here. Of course, here's the power transformer. These Tektronix transformers are beautiful. Bottom looks fairly clean. Of course, that was protected from the outside dust and dirt. Look at this banana plug here. See that screw that holds the wire in? If you had this end connected to a high voltage point and you went to pull that plug out, guess what? You just touched the high voltage. Be very careful. I should throw all these out. These are dangerous. So, back to the drawing board here. Right, the 150 volt supply is low. The 150 volt adjust is here. Let's see if we can parry that over that. Nothing. Alright, you can't adjust the 150 volt supply. Well, I made a little progress. Got my high voltage back. I haven't measured it yet, but 150 volt supply I got working again. Yeah, this has got some problems. What I did, I can find my schematic. Turn the intensity down. I replaced all 3 tubes in the minus 150 volt supply. I'm still unable to get this up to minus 150. I can get it up to about 144, but at least my high voltage oscillator is working and I'm getting high voltage, the high tension. I'm thinking, and I got to be careful I don't. Yeah, we got some stuff changing in here. I'm going to check a couple of the voltage rails for ripple. Here is C601 in the minus 150 volt supply, and I'm measuring the right side of this resistor here, and that ripple doesn't look good. 246 volts of ripple. So, and that's that funky looking cap that was siliconed to the chassis, and that was suspicious at the beginning. So I'm going to replace that cap for sure. I'm going to let this run for a little bit. Maybe some of these caps will come back somewhat to life, and we'll see what happens. But even though I've got my voltages back, I still don't have any high voltage. So I guess the next step will be to check the oscillator. Here's how the high voltage is derived here. You have a 6AQ5 operating as an oscillator, and that drives this transformer. And then the output here, you've got these high voltage rectifiers here that produce the high voltage. Then there's a feedback system here that comes over, and then both sections of V10, A and B, they have a feedback network here that controls the oscillation here. So we have no high voltage, so I'm going to first check and see if this is oscillating. I have a feeling it isn't. I think normally if I was going to keep this scope, I would probably replace these vacuum diodes with high voltage silicon diodes, which you can get now. You can get them 15-20 kilovolts. So, and you won't be able to find any more of these. And here you have 2235 volts on the side of the CRT here, and then you've got on the cathode minus 1675 on the cathode. And they accelerate of course they accelerate the beam to the phosphor on the front of the screen here. First thing I think what I'll do is measure on the plate of V705 and see if I have oscillations. Also, I'll check the 300 volt supply here to make sure it's getting voltage. When you replace these capacitors here, this is some new old stock that I have, and they come with this, looks like a fiber, some kind of a phenolic material, and then it comes with a metal piece. You don't want to use a metal piece because this cap has to be isolated from ground. This is for a negative supply, so what you need to do, just use the phenolic piece and then turn these, what are the grounds, turn them to lock this in place, and then when you bolt this in the circuit through these two bolts, this will be completely isolated from the chassis. So you don't want to use this because this would short out the negative of the capacitor to the chassis, and that would be not good. Just a little thing to watch when you do this kind of stuff. C601 is replaced now. I had some new old stock caps here, and they're connected across these terminals here. These screws here, to get these started, was a real pain. I needed a third and fourth hand, so Patty came to the rescue. So that cap's replaced. Here's the acceleration voltage on the CRT. It's supposed to be 2,325 volts. So I'm going to use a Fluke 1000 to 1 high voltage probe, and I'm going to probe the output, and we only have 1,030 volts on the I guess you call it the second anode, or high voltage connection on the side of the tube. Our high voltage section is not working, so I need to go back and make sure this is oscillating. V705, a 6AQ5. I'm not sure if I have any of those. I might. Let me see. .6AQ5A. I don't know if that's close enough or not. I'll have to check and see. A lot of 12AU7s. I got a ton of those. So anyway, I'm going to make sure the oscillator circuit's working. Here's the oscillator, and we've got our feedback system here. Obviously that's not going to work. I need to see. Now the tube filament is lighting up here. I can see that visually. Anyway, let's check and see if the oscillator is actually working. Before you do any work in the high voltage section, it's a good idea to go in and make sure there's no residual voltages or charges that can surprise you here. I went in and I measured and everything is 0, but I'm still going to go in with my shorting resistor. This is a couple K with a ground and a probe, and I'm just going to touch each of the terminals to make sure there's not going to give me a surprise. This line right here, this is the high tension lead that goes up the acceleration voltage up on the neck of the tube here. That's the one you want to be careful of, because that tube is like a big capacitor. It stores a charge on it. And I'm just going to make sure, not only do you not want to hurt yourself, you don't want to hurt your measuring equipment. If you go in there with a regular voltmeter and get on 2,000 volts, you know, you're going to make basically a piece of junk here. This section's still a little dirty. I cleaned some of it up. These are your high voltage rectifiers here. If I was going to keep this and use it a lot, I'd replace these with solid state ones. There's a lot of these that should be replaced probably. I'm going to check those now. I should probably check the tubes that run the high voltage. They're located under here. You've got the oscillator tube and the regulator tube for the oscillator. They're mounted under here. And of course they oscillate. This is your high voltage transformer that generates the high tension. And then they're used in the CRT circuitry. Okay, I'm scoping pin 1 of the oscillator, V705. It's a 6AQ5. That point would be right there on that 47K resistor. And it is oscillating, you can see here. So, still no high voltage. So I'm going to replace the vacuum rectifiers, the 5642s, and see if we get our voltage to return. Hopefully it's not the transformer, the high voltage transformer. If that's the case, which is T1 here, then we got big problems. Well, I checked my stock and I actually have 5 5642 high voltage rectifiers here. Oops. Maybe I got 4 now. Anyway, look at, there's a carpet. And of course they go here in the high tension supply here. So since my oscillator is working, I am going to replace these diodes. Ooh, I already checked. And I will see if it comes to life. If not, unfortunately this might be bad, and that will be bad because those transformers are not available anymore. So that's next. Here's the old rectifiers, and here is the new ones. Next step is tune for minimum smoke, hopefully. Well, we've got high voltage back. I just connected the horizontal deflection plates, and I can't get the focus to, I think I need to adjust some voltages, but at least we're getting there. Let's see. I'm going to connect the vertical plates and see if we get any response. Well, I reconnected the vertical deflection plates, and I didn't get any trace. I believe it may have been thrown off the screen here, deflected off the screen. I disconnected one of the plates and it came back here. So I think I still have some adjustments to do on the power supply, and also I'm going to check the vertical system to see if something must be out of balance here, why it's throwing the trace off of the screen here. So I'm going to look into that next. Okay, I have high voltage. The oscillator's running, and I'm measuring on the high tension line that goes to the CRT. And what I'm watching for is when I lose my high voltage, which it goes out after a few minutes. And it's low, it's only 1672 volts. But what I want to see is when I lose my high voltage, does the oscillator continue to work? Because I'm not sure if the problem is with the oscillator driving the transformer or in the high voltage section. Now, replace these rectifiers. Right now I'm measuring pin 1 of the oscillator, and that's what you see right there. It's still holding up. It takes a couple minutes, and then before I had any instruments hooked up, I would lose my, and I still can't focus it, so I still got a problem here with a high voltage, that it's low. That should be 2225. So, well, anyway, there is a little distortion in that signal I can see up here. The tubes test good, so I'll give it a minute, see what happens. Yeah, I still can't focus the beam. You can see the high voltage is dropping slowly. The oscillator is still working, but that seems to be dropping slowly in voltage too. It's dropped just a little bit. And now I can't see. There's nothing on the CRT either. Underneath these two porcelain strips with these components are the inverter oscillator and regulator under here, and these components are involved with that. The manual doesn't show, there's no pictorials of these, what these components are, so I redrew them here for reference, and they're in that order from back to front, back to, or the side here coming towards me. You got the 390 ohm resistor in the back there, And then in the end here you've got this bumblebee, or whatever you call it, cap, C714. Well, I've got the high voltage back partially. It's still low. This should be 2325 volts. I'm only getting 1463 on the high voltage connector on the side of the tube. I still got a lot of problems. What I'm going to do, I ordered some high voltage diodes. They're 20 kilovolt 5 milliamp diodes. I ordered a bunch of those, and I'm going to replace the vacuum rectifiers, the 3 of those in the high voltage section, and that'll take some of the load off of the high voltage transformer because it won't be driving the filaments of those, and that might help. But I still got a low high voltage here. I did replace quite a few parts. Here's a bunch of old tubular capacitors here. They're like an oil, paper oil impregnated cap here. I guess you call them bumblebees or black beauties, whatever you call them. I also replaced a 6080 tube here. This is in the power supply. It's a regulator tube. I got a bunch of these, and that seemed to help. Originally my minus 150 volt supply was off. It was real low, and I was able to fix that. There were a lot of transplants in this thing I had to replace. Here you can see these poly caps here. They replaced some old caps, and I got 2 electrolytics here. These are, let's see, I think they're 22 at 450 volts. This is that big can cap I replaced. That's the only one of the big ones that were bad. The others were okay, and that brought back the 150 volt supply, the minus 150 volt supply, and I could adjust that. The other supplies came up fine. It's got a 300, 100, and minus the minus 150 supply. They're all working right. So far the only problem is the high voltage, and hopefully a transplant with high voltage rectifiers will solve that problem. I had to replace a number of these caps here. Sprague 0.015 at 3000, and had some others here. I think 6800. But anyway, I didn't have the exact values, so I had to create them. I paralleled some ceramic discs here. These are 3 kilovolt caps. I put them in parallel to get the proper capacitance. Same thing up here. I did the same thing. And these caps were all replaced in this section here. Here again is a high voltage transformer. For some reason this thing's getting loaded down. I'm going to replace these 3 vacuum rectifier high voltage rectifiers with silicon diodes, and that will take the load off, some of the load off of the high voltage power supply. Filaments for these are a couple turns of windings on this transformer here, and of course this runs at a high frequency. I think it's 60 kilohertz. I have to look it up, but anyway, taking the load off of this might help with the high voltage. These are known to have problems here. You can see these lines coming down here, the heavier lines. These are the filament lines that feed the 2 pins on the, well, if you look at this tube here, there's 2 pins here. These are the filaments, and then the tip here where it comes to a point is the anode lead, the high voltage. So that is something else I'll have to do. I need to clean it up a little bit too. I spent too much time on this thing. Here's the only big cap I had to replace. And of course this one has the silicon diodes in it, didn't have the seleniums. Here's your inverter, oscillator, and regulator here that drive the high voltage transformer. If anything else, this will make a nice donor. It has a tag on it that the CRT was replaced, and the CRT is in good shape. And of course the transformer, these are wonderful transformers that Tech has. Can always use more donors. If I do get this thing running up to par, I'm not going to go through a whole bunch of calibration on it because I'm really not going to use it. It's only a 15 megahertz scope. So anyway, I'm going to close this one down pretty quick here because it's getting too long. I may have another video on this if I get those diodes and I can get the high voltage working properly. I may put an addendum. We'll see. Anyway, that's it for this one. Thanks for watching. Unable to get it working back 100%, but at least you saw it's starting to come back a little bit. So thanks for watching and see you next time. Bye for now.